Little help from the website Desmos.com. I'm going to help you guys understand translation, stretching, and shrinking of graphs. So one of the easiest equations to see this with is y equals x squared. So when I graph y equals x squared, I have a parabola who has a vertex at 0, 0. So let's take a look at some different translations first and see how they affect it. So let's see how it changes if I add a value to it. So the blue is my new parabola, and its vertex is at 0, 4, which means it moved up 4 units. Let's try subtraction and see what that does. If I subtract 4, here's my original equation, and it moved down 4. So when you're adding or subtracting to the end, that's going to be important in a minute, to the end of an equation, it will shift you up or down. Now, what we're getting confused in the discussion area is what happens when I do it inside of the x value. So let's say I have x minus 2, and I'm going to square that. Now, most students are saying that they believe that is actually going to shift it to the right, to the left 2. That's not the case. So I'm subtracting 2, and most people have said, well, if I subtract, I'm going to go left. That's not the case when you're translating horizontally. You're always going to move in the opposite direction. So even though I'm subtracting 2 and my mind says, well, minus 2 is left, it's actually 2 units to the right. So let's just see how this works with another number. If I add 1, it's going to the left. So this is the way I tell students to remember this. Vertical goes the same way, horizontal goes opposite. That's how I want you to think about this. Vertical goes the same way, so if I add 4, I go up. If I subtract, I go down. But horizontally, it's going to change things. So let's look at one that has both shifts happening at the same time. So I'm going to add 3, which is going to shift me to the left 3, and then I'm going to subtract 1. That is 2 transformations that are happening here. I'm going from 0 to left 3, then I'm going down 1. So that's how we're going to be shifting with movements, okay? Let's take a look at reflections. So if I have y equals x squared, if I put a negative in front of it, it will reflect it across the x-axis. However, when we are working with a translated equation, this is going to be a little different. So here's my translated equation. I moved it to the right 2, and I shifted it up 1. So this is what I want to reflect across the x-axis. So I want that vertex to be down here. What does this do? Is that a reflection about the x-axis? Let's look at it again. It's here. If I put the negative in front, that's not reflecting across the x-axis, right? No, it's not. This is why. Because you have to distribute that negative to everyone in the equation. So if I do this, look at what happens there. Now it's reflected across the x-axis. So that's the really tricky part, is when we're reflecting across the x-axis, we have to change every sign. So if you're adding or subtracting something, that sign has to change as well as putting the negative in front. Now, if I want to reflect across the y-axis, that's a little bit simpler, okay? So if I want to reflect across the y-axis, this is already symmetric, so it's really not helpful. So let's look at another equation for that. Let's look at x cubed. Now, we already know the negative out front is going to change it, and it's going to reflect it across the y-axis. What happens if I put the negative inside of the parentheses? So let's see how that changes things. Does that change anything? No, because it's a cubic. That's why. So when we're dealing with a cubic and that reflection, we've got to be cognizant of that. Now, the same thing is going to apply if I want to shift this number. So if I want to reflect this across the x-axis, I need that vertex, well, I say vertex, I need this point to be here at -1. Does that happen? No, that does not happen. And it's because I have to change the sign as well. So I'm going to have to change the sign to be able to do that reflection if I want to go all the way through. Now, is it symmetric? No, that's definitely not symmetric. I'm reflecting it across the y-axis. I had to shift it and adjust that. But because it's an odd function, it's a little bit weird of a situation. So let's look at the square root of x. And let's see what that does. This one might be a little easier to reflect for us than the cubic. The cubic gets very confusing because it doesn't want to do that reflection across the x-axis. So if I put the negative out in front, and I just have square root of x, it will reflect it. But if I have something like square root of x plus 1, in order to reflect it across that x-axis, I'm going to have to change all the signs. So it's not as simple as putting a negative out front. That's where the mistake commonly happens. If I want to translate it horizontally, I'm going to have to do that under the root. So if I'm under the root and I add 2, let me get this off here so it's just easier to see. That is going to move it left 2. So that's going to be that backwards translation we talked about. So inside the root, it's moving backwards. Outside the root, it moves up or down. So I hope this kind of helps straighten out the translations and transformations that are happening for you guys in the assessments. The reflections are definitely tricky. The key there is to remember if you have something being added or subtracted outside of this x term. So here, if I have things being moved, I have to alter signs. So when I do that, if I want to reflect x plus 2, it's up here, I have to put the negative in front. It doesn't affect what's inside. It only affects if I'm adding a number outside. So if I'm adding that number outside again, I have to change that symbol so that I get that symmetric reflection.